So this is the start of our nitrogen use efficiency work at Cawood, where we're looking at barley, both hybrid and conventional barley, and looking at how we can influence the efficiency of the crop and the dose of nitrogen required. So we have here a range of nitrogen doses, working our way from 50% nitrogen all the way up to 125%, with the 100% dose being the standard field recommendation for this site. And then what we're doing is looking at how we can influence the response to nitrogen with various biostimulants, various alternative sources of nitrogen, and more efficient uses of fertiliser to manipulate the dose response curve that we'll create using these plots. So at 100% dose, we can take the yield from that, and then if we cut back the dose of nitrogen by 25%, and plot the yield for that and look at where that is on the nitrogen dose response curve, we are then looking at various technologies to bridge the gap. So taking a 75% dose of nitrogen and then alternative source of nitrogen to try and achieve the same yield as we're achieving with this 100% dose. The reason for that is to try and diversify the sources of nitrogen in the crop. So if we have a dry spring and the nitrogen applied isn't getting into the plant, we have other ways of getting nitrogen into that plant and we're not compromising the yield. With biostimulants, that might be by using phosphites early on. It might be by using pedolic acid to improve the efficiency of nitrogen getting into the plant. We're also looking at biologicals, including bacteria. One of those is a rhizobacteria, which fixes nitrogen in the soil and feeds the root zone. And another product is an endophyte, which fixes nitrogen within the actual plant and is applied as a foliar spray and colonises the plant cells and fixes nitrogen from the atmosphere directly into each cell, feeding the chlorophyll, and we see a greening effect from doing that. Both of these are ways in which we can provide an alternative source of nitrogen into the plant. A final way we can provide alternative nitrogen is by using efficient urea. Urea polymers can be applied as a foliar spray later in the season, and these provide an efficient source of nitrogen directly into the leaf. They're on a slow release and feed the crop for a protracted period of time, so from between 6 and 8 weeks. And again, this is a way we can bridge the gap, removing the requirement for as much synthetic nitrogen applied as a granular product.